Math is clean, math's easy when you're doing math with Miss Lee.
This is part 2 of a series on integration by trig substitution. So again, usually I look to use trig substitution when I see sums of a variable squared and a constant, or differences between the two. This has a sum of x squared and a constant. I'm going to match that to the trig identity tan squared theta plus 1 equals secant squared theta. So that means that I will need to replace the x squared with tan squared theta, or x equals tan theta, and then taking the derivative of both sides, dx would be secant squared theta d theta. So now I'm ready to substitute. In place of the dx, I need to put secant squared theta d theta. In place of the x squared, I have tan squared theta. And then in my radical, that's going to be tan squared theta plus 1. So working with the trig functions, I'm going to simplify a little bit before I anti-differentiate. The square root of tan squared theta plus 1 becomes the square root of secant squared theta, which then becomes secant theta. And then I'm going to divide my numerator and denominator by a secant. And now I'll work a little bit with some more trig identities. Since secant is 1 over cosine, and tangent is sine squared over cosine squared, I'll keep change flip, and this becomes cosine over sine squared. I think I can work with that. So now I'll go with a regular u substitution. I'm going to let u equal sine theta, which means that du will be cosine theta d theta. So now substituting, I really have u to the negative 2 du. Taking the antiderivative, I get negative u to the negative 1 plus a constant. So now I've got to get the theta back in there. So that's really 1 over sine, which is really negative cosecant. And now I end up in a situation where I have a trig function that I did not use to substitute. My original substitution was that x equals the tangent of theta. So this is an example that's going to require a right triangle. So to make a right triangle, I'm going to set it up so that theta is one of the acute angles, and I want the tangent of theta in this triangle to be x over 1. So here's opposite over adjacent, and if I use the Pythagorean theorem, the hypotenuse of my triangle will be the square root of x squared plus 1. I want to point out that that ends up matching part of my original integral. I had the square root of x squared plus 1. So that's something you should usually expect to happen when you have to use triangles. So now cosecant is hypotenuse over opposite. So in this triangle, that's going to be the square root of x squared plus 1 over x. And that's what I end up replacing the cosecant of theta by. So my final answer is negative square root of x squared plus 1 over x plus a constant.